Hi there, my name is Alvin, and today I will be explaining how to use knife bias in Python Jupyter Notebook. But as you can see, I'm not using the other Maniconda Jupyter Notebook. I'm using Visual Studio Code Jupyter Notebook. But you can certainly use the other Maniconda Jupyter Notebook if you have one. But for now, I'll be using Visual Studio Code Jupyter Notebook. Okay, so first, here are all the other package that you will need to use or that we will be using for the other knife bias sentiment. Here we have pandas package and then as well as numpy and then natural language toolkit as well as regular expression and then sastrawi. This sastrawi here is a stammer and I'll be using sastrawi for my stammer because I'll be using Indonesian language data. But if you are gonna use a different language, I suggest finding a different stammer because this stammer here, Sastrawi stammer, is only for Indonesian language. But you can certainly find a other stammer that is compatible with your own language. Yeah, so Sastrawi here is optional or that can be changed with other stammers. Okay, anyway, let's continue. And then you need a scikit-learn package. This will be all the other necessary tools to do knife bias, especially when I use multinomial knife bias. And then finally, you just need Google Play Scraper to get the data from, or the review data from Google Play. All right, here, there is all of the other packets that you'll need to download and use for the other knife bias sentiment. All right, the next part is to get the other data, so obviously. Here is how we're gonna take the data. We're gonna use Google Play Scraper to get the other reviews by using the other reviews method, and as well as the other sort object. Here we have a variable review sample. Now, review sample here can be put type in straight away like this. But I'll be using a variable because I will be using the other variable again at the final result. Then you just need to make a variable of result and continuation token. Continuation token is just to, I think, separate the continuation token from the review. So how do I use the other reviews method from Google Play Scraper? It's actually very simple. This here, OVO ID is here the ID of the app that you'll be using. Right now I'll be using OVO ID, and to get the ID, you just need to open open Google Play on your chosen browser and get its ID from the link. For example, if we get the ID for OVO right here, you just need to click the other app name, and then you can then get the ID from the link up here. You can see there's ID equals OVO.id. You just need to get this one here, and then just need to copy and paste that into here. Let's try that again. This time with Amazon. Let's try to go Amazon. You just need to then click on the other app name or any app, and then you just need to copy this. You can see ID equals com.amazon.shop.android.shopping. Just copy that into here, like so. Language, since I'll be using Sastrawi Stammer Factory, I'll be using the Indonesian language to filter out only the Indonesian review. Then as well as country for Indonesia. And then you need to sort that uh, review. I'll be using most relevant because it's the most common sort data and also the most uh, down to the core, I don't know, like the most obviously relevant to the app. And then the count, I already explained that, is the amount of review sample count or the review you did taken. And then filter score, set it to none. Why? Because we need to get all the score, negative and positive. All right, after that, turn that into a data frame. This here will turn it into a list of reviews, and then just pop that into and turn it into a list of data frame. Let me just see how it looks like. So the underscore app data dot head. There we go. Yeah, it will look like this. Now why can't we just take this one straight away because we already turned it into an array? Is because well, it's it is an array or a list, but it's not a data frame. Let me just show you right here. Give me a moment. So if we dot head, nothing appears because this is not a data frame or a list of data. And it's not a data frame or an array. So and it's not a data frame. So we need to use print instead to get how it looks like. Yeah, there we go. This is how the other raw review looks like. It's just a mess. And again, this is how the other frame one looks like. Alright, on the next step, that is just filtering out the other column we need and as well as sorting it by the other date. So here we can see that app data equals app data array, select array, or select column. And here we're only gonna take the other username, score, the time, as well as the other content. And then we need to sort the other data by the time. Ascending equals false. And then we just need to select the content and the score. Turn it into a new variable. We're gonna call it use app data. And then we have to let use app data into uh, a CSV folder, just so that we don't need to wait again for the other scraper to scrape all the data. Because if you're gonna scrape a large data like I did here, 15,000 reviews, it will take like 5 minutes. For me, it will take like 5 minutes. But it could be, but the time you need to wait may vary. Hence why we download it into a CSV file. So when we want to run it back, we don't need to call this thing again. We just need to call this thing. Yeah, we just need to call the other CSV file. Okay, now on to scoring. Now we just need to make a function for the scoring. So anything below 3 it will be negative, and anything above 4 or equals to 4 will be positive. And yeah, you can see that the one or rather the reviews with the score of 3 or the 3-star review will be none. Won't be rated or won't be scored. Well, that's because we're gonna remove that data since that data is considered neutral and we can't have neutral data in our naive Bayes sentiment. So yeah, we're gonna put that into a new column here. I'm gonna call it a scoring label, but you can call anything you want and put that score into here. Let me just show you how it looks like. I think I can. Hang on. No, I can't. Yeah, let me give me a moment. So with CSV, I need to read the other CSV from me. Moment. Where is it? There it is. Hang on. There it is. There you are. Run it. Yes, I know. I forgot to split this. There. And drop this. Don't need that right now. And to read this one. What's missing here? Buffer. Oh, get the copy relative path. Let's do that. Oops, this one remove. There we go. Just write that. Now I can put it here. This head. There we go. Yeah, there we go. You can see now that we now have the scoring label down here. Previously, it will look like this. Not like that. Previously, it will look like nothing. That's because I think I need to print it. Data. There we go. Yeah, if we look like this, there's no scoring label. Or rather, there is, but we haven't connected to it. Oh, wait, no, there is. Oh wait, I think that's because I already have. Oh, wait, never mind. Wait. Right. So yeah, that's what the other scoring does. It's just if the other review or the data score of positive or negative, and then we can get then we can download that back again into a CSV file, so we don't need to repeat the other review again from up here. Don't need to repeat this thing again. Then again, I already showed you this. This to read the other CSV. So we're gonna read the other CSV knife bias cleaning needed. This one we just created here. And then we're gonna drop the other data that is null. So yeah, we're now into the cleaning process of the cleaning the data. So drop any here, basically just drop any data that has a null value. In this case, we want to drop the other data that have a null value in scoring label. So if the data, let me just see here, cleaning needed, there it is, that is the data I should downloaded. I think this one, yep, this one here. You can see that in the other scoring label table column here, you can see that some of the data is here, for example, has 3-star rating, and it's empty. That's because it's considered neutral for it to have a rating of 3. And that's why we have it neutral here. Yes. Neutral, empty, neutral, empty, neutral again, empty. We want to remove this data here. If it's empty, we want to remove it. So yeah, that's what .NA do. It will read the scoring label data in a row of data, and if it's empty, we will drop it. Then again, we're gonna dump it back into a CSV file again for easy reading. Easy reading. I mean, it is easy reading since you don't have to restart on the entire process again just to get the other data. Right. Next step is to clean the data from special characters. So any non-alphabetical character like number, emojis. Let me just, for example, this emojis here is a non-alphabetical uh, character, so it'll be removed. So it will get removed. This comma here is non-alphabetical, so it get removed. Then this comma as well, this number as well, and yeah, this emoji here again, this dot will get removed. Yeah, so that's what we'll be cleaning it from. We're gonna remove any non-alphabetical character like numbers, emoji, and special characters. This is to remove that, but first we need to lowercase the string, since it will also remove any uppercase strings. Right. This is the function of it. We then need to obviously use that function first. We need to lowercase the other string first before we clean the other characters or clean the data. And then we put that into the other clean text column that we just created here previously. All right. Now for stop words. Stop words itself already have a library of word that is considered are not important for us. Basically, like any conjunction words will get removed. And let me just show you here. Here we can see that aplikasi sampah masa pakai tutup dan istirahat. Here we can see the clean text. We have the word masa done, and that will get removed. Here we can see the stop word text that we just run from here, the column stop word text. Which will remove the other data if it's in the other stop words. If it's not in stop word, then we'll just join it back in together and put it into the other column, stop words column. Now take a look again. Masa has been removed. So masampah, masa pakai turn to sampah pakai. And then this will get removed. That's considered conjunction. Not junction word. It's something like some kind of word I cannot remember. But yeah, any word that isn't just do like junction or conjunct, yeah, the sentence will get removed. So that's what stop word does. Next is tokenize. Tokenize is very simple. It just turns the other every words into an array, or yeah, the sentence into an array of words. So for example, here we have aplikasi sampah pakai tutup istirahat aneh jam. It will be turned into an array of words. So we have element aplikasi, and then element sampah, and then element pakai, and then element tutup, and element istirahat, etc., etc. So that's what tokenize does. It just turns it into a array of words. All right. And after that, we can stem the characters or the word. As I mentioned earlier, I'll be using Sastrawi stammer. That is the stammer for Indonesian language. So the other technique may differ. So I recommend reading the other stammer documentation. But if you're like me, we will use Indonesian language data. And yeah, you can just follow the steps. First, we're gonna call the other stammer factory object or the class and turn it into an object. After that, we're gonna call the other create stammer method from that object and then into a variable itself. And then what we want to do is to just make a new object and call it anything you want. Same for the count as well. Count is count how many data in the other dictionary. All right. Now we just need to loop every word in the other tokenized text or the every data in the other tokenized text. And then after that, we want to loop every words in the other data itself. So for example, we're gonna take data one and take its tokenized text, and then we're gonna take that tokenized text and take every text from that array. And then we're gonna check if it's in the dictionary or not. If not, then put that into the dictionary. And so that's what this does. It just basically takes every word and put it into the dictionary. And if the other word is in the other dictionary, it won't put that in. But if it's not, then it will put that in. Right. Now this is just to check the length of the data. So from the 15,000 data I just took, there's now 15,968 data because there's a lot more words than data in here. Or there's a lot of words in the data. Yeah. And next, you just need to stem every word in the other dictionary. So for example, here we have term, or we have gonna take the other dictionary here and just count the dictionary, how many words in the dictionary. And then after that, we're gonna stem every word into its core word. Now what stemming does basically just turn every word into its core word. For example, if I have the word destroying, it will stem it back down into the word destroy. And for another example, if I have, let's see here, creating, we have the word creating, it will then pour it down into create. Hopefully you get the idea. That's what stemming does. Okay, then now here we have get stem term. It's basically just the other gonna return every words in the other dictionary. And then we're gonna put that into the other stem text column. We're gonna make a new column in the other data clean. Let's do it. Clean here. We're just gonna put it into the data clean variable and make a new column there. Called, and then you want to call it stem text, and just put that data into here. We're gonna loop through every word in this tokenized text, and then apply that with the other get stem term. Then we're just gonna get the other all the core word from the other tokenized text. There isn't much to see here, I don't think, because there it is. So Panorama turn into Trima. And then if I can find it again, I don't think there is anything. There it is. Bermuda turn into Muda. And then I think that's all of it. Let's see. There is berulang turn to ulang, etc. etc. You get the idea, hopefully. Okay, now to the main part, knife bias. Knife bias. Now to do knife bias, we first need to turn the data into a multiple variable. Now this is just to make a train of variable. I think what train does basically just here then split arrays of my or matrix into random train and so test subsets gitu the other also the documentation. So yeah, first we want to take the content from data clean, then the content from or the data from scoring label. So if the content, we gotta take the content as well as its scoring label. Then train size or test size, yes, set 0.2 and randomly 0.80. Alright, after that we need to factorize the other data. This factorize here is just an object. So I can turn the factorize dfid factorizer to an object. And we're gonna use here the fit transform method. It's basically just just have to, and then for the test, we do the same thing for the other new variable here, dfid def so test. We're gonna factorize it again. This time we're gonna use transform of test x. We're just gonna use the test x as well as then train x for this tube here, and then count factorizer. We're gonna fit that train x into get a count factorize. Then I will just transform the other both of the data into after fitting it into the count factorize, then you need to transform the using the count factorize again. Test x and test x. Alright, into the multinomial knife bias now. We're gonna fit the other dfid train here, df train fit underscore transform, and then we're gonna compare with the other y, train y, the other raw data. Then we're gonna turn the other train x into an array for the other array. Yeah, here just put as a prediction. So we can predict the other y by using the dfidf dot underscore test variable. So predict y. So if this variable can be any name, but then we'll predict underscore y is to predict the other dfidf underscore test, which is this transform version or the dfid underscore factorized transform version of df test dot underscore x. And then we're gonna compare that with the other test y variable here, the raw data. We basically just comparing the other the transform data with the other raw data of test and train y. So train y here, or train x that has been fit underscore transform will be compared or fit by train y, and then yeah, the TF-IDF underscore test here will be then predicted, which is a transform of test underscore x will be then predicted by the naive bias and turned into put into variable predict underscore y, which will then use to compare, so we can get the accuracy score, or compare it with test underscore y or test underscore y compared with predict underscore y to get the other accuracy score. Right, that's all the other predicting you need to do for the other naive bias. Now we can get onto the printing result uh, section, where we're gonna use the multinomial naive bias class here, turn to object, and then we're gonna fit the other also yeah, we need to make a new object of multinomial naive bias. We're gonna fit the other train x and train y into the final NB, and after that we're gonna make a final prediction. So final NB dot predict test x, and then after that final precision, this is gonna take the precision score from test y and final prediction average with the binary. Yeah, after you're gonna use binary average, and then the post label will be negative because you got the negative score, and then final recall score will be test underscore y, and then you're gonna compare it again with final prediction, same average and same post label, and F1 score again compare test y with final prediction, same binary average and same negative post label. And then for classification report, we'll be using test y final prediction and zero division is equal to 0. And after that, we just need to get the confusion matrix, which are we just gonna call it the method confusion matrix, and we're gonna compare test y with final prediction. After that, we can just print all of the accuracy. Where is accuracy? I guess we just need to call the other. We just need to call the other accuracy score, and that is this thing here that we just get previously. Then the final precision, then final recall, this variable. Yeah, then we just need to print all of the other variable now from the other naive bias. And after that, the classification report. Now, again, as I stated, I put the other review count in a separate variable. And that's because I want to just print it out from how many sample I just took this from. So here we can see review sample, the same variable up here. The review sample is 15,000, so that means this will say taken from 15,000 samples. That's why I put the other sample count in a different in a global variable, so that I can just easily print this as well as a proof that of how many samples I just took for this naive bias. And once you run it, the output should look like this. And you can see the accuracy score minus 85%, and precision score of 92%, and then recall score of 97%, F1 score of 95%, and condition matrix of 2300, 23,000, or 2300, and 49, 178, and 257. Yeah, here's the other classification result. You have precision on negative, you have 93%, recall 98%, and F1 95%. Accuracy 84%, positive, and recall positive is 59%, and F1 is positive is 69%. Nice. Support is the other combination of the other confusion matrix. So the top one is positive and the bottom one is negative. Yeah, so the accuracy is all the combined accuracy and as well as the other confusion matrix. Alright, hopefully this video has been helpful, and I'll see you next time. Thank you.